In this video, I'm going to go through question 4 of my tricky parts per notation questions. Question 4 reads, bronze is made of copper and tin. Copper has a concentration of roughly 12% W over W. If the density of bronze is 8.8 grams per centimeter cubed, what is the concentration of copper in mole per decimeter cubed? So what we need to work out for this question, we need to work out the concentration of copper. And the concentration of copper is equal to the moles of copper divided by the volume of bronze. And this is equal to question mark. We don't know this yet. We're given an alternative concentration of copper in the parts per notation, specifically the parts per notation of percentage with the fraction W over W. Now the equation for this is W copper over W bronze times 100 is equal to 12%. Now, what we need to do, we need to go from this equation to this equation using the density and some other things. So first what we're going to do, we're going to write the equation for density. So the density of bronze is equal to the mass of bronze divided by the volume of bronze, which is equal to 8.8 gram per centimeter cubed. Now, because our final answer needs to be in moles per decimeter cubed, we need to convert this density into mole per decimeter cubed. So this is 8.8 times 10 to the 3 gram per decimeter cubed. Okay, so we've kind of got one part of what we need. We can substitute in the density into this equation to get it a bit more like this top equation. And the way we do that is we rearrange this equation so that W bronze is equal to the density of bronze times by the volume of bronze. So now the W bronze, therefore, is equal to 8.8 times 10 to the 3 times the volume of bronze. So now if we enter in W bronze here, you can see that we get the volume of bronze on the bottom of this fraction, which is making it look a little bit more like this concentration equation, which is what we need. Now, to go from the mass of copper to the moles of copper, we use the molar mass of copper. So the molar mass of copper is equal to the moles of copper divided by it's equal to the mass of copper divided by the moles of copper. And this is equal to 63.5 grams per mole. Now, again, we're going to substitute this equation into this equation to make it look a little bit more like the top equation. So what we're going to do, we're going to rearrange this so that the mass of copper is a subject and can be entered directly into this equation. So W copper is equal to 63.5 times the moles of copper. So now we've got both equations that we need. So we've got this equation and we've got this equation. We can enter them both into this equation to get this equation looking a little bit more like this equation. So let's do that. So we know that W copper is 63.5 times the moles of copper. And we know that W bronze is equal to 8.8 times 10 to the 3 times the volume of bronze. And if we times this by 100, we get 12%. So now you can see that this bit looks exactly like this bit. So what we need to do next is rearrange the numbers in this equation so that we only have the N copper over V bronze on the left-hand side of the equation. So that's what we're going to do. So 12 divided by 100 times 8.8 times 10 to the 3 divided by 63.5 is equal to our moles of copper divided by our volume of bronze, which is equal to our concentration of copper. So now what we can do is we can use our calculator to find out what this is. So 12 divided by 100 times 8.8 times 10 to the 3, which will be divided by 63.5, which means our concentration is rounded to two significant figures, is 17 mole per decimeter cubed. And that answers our question.